click that. All right. So the warm-up asks two questions. Now, some of you were answering just the second question, but you don't forget the first question, okay? So the question is, it says, when we talked about moving figures, so moving figures, right? Moving shapes are called transformations. When we talked about that yesterday, what did we mean by a rigid motion? So when we move these figures, when we move these shapes, some of these movements are rigid. Actually, 3 of them are rigid, right? So what are the 3 that are rigid is the second question. But the first question is, what is a rigid motion? So what is that? What do we mean by rigid motion? And I'm looking at you. Okay, there you go. A lot of you are saying by rigid motion, we meant when a transformation keeps the same size and shape. Exactly. So when I had a shape like this and I moved it, right? I moved it and I had a new shape, right? The pre-image is the original shape and the image is the new shape, old, original, new, pre-image, image. It keeps the same size and shape. So rigid just means I move it, but I don't alter it, right? It stays the same, right? And the one thing we also said is if I do a rigid movement, it keeps the same shape and size. That means these 2 things are congruent, like we were talking about last semester. So good job. And the three transformations that are rigid are, do you know all 3 of them? Translation, rotation, reflection, right? Translation means I get it here and I just slide it side to side, or I slide it up and down. That's a translation. Rotation means I change the orientation. I rotate it like this, or I rotate it like this around a point. I rotate it around something, right? I have to have a point and rotate around it, or it can rotate on itself. And then reflection means like a mirror. I have this and I have a line of symmetry and then I reflect it to the other side. Okay, that's a reflection. And those 3, we don't change the shape. Now, there's the 4th one called a dilation. That changes the size of your figure. So if I start here, this tiny, tiny square, and then I do this, now it's larger and blurrier. But yes. So for you to remember these 3, I told you I'm going to play this song for you every day that we do transformations. It gets, it's an annoying song. I agree. That's what my students last year said, but they would come into class humming it, or they told me, Mister, it's stuck in my head all day. And it helps us learn the 3 rigid transformations. There is a 4th, but this song talks about those 3. So let's go to that song. All right, where is it? There it is. Transforming that shape, there's a few options that are available to me, because I could rotate, turn it round, translate, shift it left, right, up or down, reflect, copy it across an axis of symmetry, rotate, turn it round, translate, shift it left, right, up or down, reflect, copy it across an axis of symmetry. Hey. Right, there you go. Rotate. Everybody, turn it round, translate. No? Nobody? Hello? Okay, I guess it's only me. So you're at home right now singing it, right? Some of you at least. Hold on. Hold on, let me let these people in. So yeah, come on. You guys are singing it at home, right? Rotate, turn it round, translate. No? Nobody? All right. It's only me. But I'm going to play that every day. Maybe it's like those annoying commercials, right? Well, you won't get a lemon. Right? You know, these annoying, I've had that song in my head since I was 4 years old. It's just annoying songs that get stuck in your head, right? And Ah, my computer is acting dumb. Okay, it's like those annoying commercials. And what's the reason why those annoying jingles get stuck in your head? Because that's how your brain works. That's how your brain works. Music sticks faster. So I will be playing that every day. Rotate, turn it around, translate. No. Okay, so I will be playing that every day so we can. All right, are there any questions about anything? So let me remind you. In Schoology, I want to remind you all the time, in Schoology is where everything, if you are lost, if you are absent, if you forgot anything, now it is your responsibility when you're absent to make up the stuff that you missed or look at the lecture or the lesson that you missed. So you'd go to period 14, you'd go to week 3. Remember, I'm only doing one folder per week now, week 1, week 2, week 3. So week 3 materials, you just click on that. And then here you see that we have translations notes and translations homework. Okay, so the notes and the homework I have separated again. The notes, now some of you are worried. Some of you send me messages. Mister, do we turn in our notes? No, you do not turn in. Everyone listening, you do not turn in your notes. It has a due date because that's the only way I could put it on Schoology for you to be able to use Kami. Okay, because some of you told me, Mister, when I open up the notes, that PDF, I want to be able to open up on Kami because I write on Kami and I use Kami and then I write my notes on Kami and then I save it to my Google Drive. Mister, that's how I do business in school. That's how I do schoolwork. And that's how I want to do it. So, and you're not letting me do that, mister. So I finally figured out how to do that. I have to upload this as an assignment, but it's not a graded assignment. So it doesn't show up on your list of assignments that are due. Even though it does say due, I know it does say due. Ignore that. It's not an assignment. If you look at your graded assignments, it's not there. Okay. The one that is graded and the one I separated is the homework. That is due Wednesday. That says tonight. We're probably going to have to have it due tomorrow night because first period we didn't finish the notes. So if we don't finish the notes, I don't expect you to finish the homework. Okay, but we'll try. But it does say it's due tonight. But if we don't get through the notes, I will change it to tomorrow night. Okay, and so that is there. And if you click that, if this was a laptop with Google Chrome on it, for some reason it doesn't work on my iPad. Next to view, it would say open with Kami, the little blue box that says open with Kami. And you can open it and you can do your homework. A couple of people have already turned in their homework and they did it with Kami, and that was great. And then the videos, if you look here, the videos are a little different now. The videos are links. The videos are links now because I record these lessons. I record them not on Zoom anymore because honestly, I didn't like the way Zoom recorded it. The file size was really small, which was great, but it was still blurry. You know how sometimes when I'm writing here and my iPad looks really blurry to you and you tell me, hey, mister, it's blurry, and I have to zoom in? Well, that was awful because then you'd go to the video later, like that's you're absent, and it was still blurry because Zoom is just like that sometimes. So what I do is I record it now on this software. File size is really big because it's clearer, but I can't put it on Schoology. So I put on YouTube, and then I put the link here. Okay, so then you just click that, and I don't know if it'll show it. Click it, send it to YouTube, and there it is. There's the lecture from yesterday. Okay, and it's if you look, it's much clearer. All right, so that's how we do that. So the videos are still there, the homework and the notes. Okay, so we're going to continue the notes again. Take out your notebook. Hopefully you have one with graph paper. Right? Hopefully you have one with graph paper, or if you don't, if you have a regular notebook with just lines, that's fine. You can still draw graphs on them, right? And so I'll give you a minute to go grab your notebook or go open the file from yesterday, or just open this file and just follow along, right? Some of you take notes by opening this up on your computer. Maybe not the homework, but the notes. Right? You open it up on your computer, and then on the side, you just start taking notes on a regular piece of paper. So I'll give you a minute to do that. There we go. So these are our notes from yesterday. All right, so I'll give you a second to do that, and while I do this. Okay, so you guys have your notes ready? Okay, someone said, give me 30 seconds. Okay, I'll give you 30 seconds. That was another complaint I had last semester. Mister, you jumped into the notes too quickly. You didn't give me a chance to go get them or open it up on my computer or my iPad or wherever you open them up at. Again, if you can print them out, I think that would be the best thing if you can print them out. Or if you can't, maybe you have a friend who has a printer and they can print them out and maybe drop them off in your mailbox, right? Stay social distance. And so we'll get started right now. Someone said to give them 30 seconds. So it's been about 25 seconds. All right. So let's recap what we did yesterday. So yesterday we talked about transformations, right? What is a transformation in general? All it is I'm moving a shape or I'm resizing the shape. That's all the transformation is. I'm getting a shape and I'm transforming it somehow, either by moving it or changing the size of it. Okay. And the original shape, the shape that I begin with, is called the pre-image, right? And we know it's the pre-image because it has regular old points, right? The end points, you see these little corner points of any shape. Each one's called a vertex. The plural is called vertices. So A is a vertex, B is a vertex, C is a vertex. All together are vertices. So if someone says the vertices of a triangle, you say, oh, all three vertex. Okay. And we know that's the pre-image because it's just regular old A, B, and C. So if we look here, triangle A, B, C. And then the moved image or the new shape is called the image, the new figure, the new shape. And we put a little apostrophe next to it to say it's prime. It's kind of like 2.0. So we have A prime, B prime, C prime. So we have triangle A prime, B prime, C prime. That's the new figure. That's the image. Pre-image is original. Image is the new figure. Mister, why don't they just say original and new? I agree with you. I'm totally there with you, but this is how math works. I tell you, a bunch of old mathematicians get together and they're like, all right, let's call this meeting to order. Let's talk about some math things we can do. How can we make it more complicated? Johnson, yes. And then, right, they have a meeting and then they agree on new words and new vocabulary. And that's how we get these words. So pre-image is original. Image is new figure. The new figure has those little apostrophes called prime, A prime, B prime, C prime. Okay. So we talked about that. The transformation can change the position, right? Turn it left, right, up and down, or we can reflect it. It changes the orientation, right? Meaning sideways, upside down, other sideways, crooked, that kind of stuff. Or can change the size, right? Bigger or smaller. And the four transformations are translations, rotations, reflections, and dilations, right? And the first three I said were the ones that were rigid. And so that's the next thing we talked about. Which ones are rigid? What does rigid mean? And which ones are rigid? So rigid means when a transformation preserves, which means keeps, the size and shape of the figure. Okay, bam. I move it from, that's my original image, that's my new image. They are exactly the same. It preserves the shape and the size. So that means all corresponding sides and angles of both images, the pre-image and the image, are congruent because they're exactly the same. I didn't change the size or the shape of them. So they're exactly the same. So they're congruent. So that means all the angles are equal. All the sides are equal. Okay. And translations, rotations, reflections, like we rotate, turn it round, right? So those are the three that are rigid. And so we started focusing on the first one, which is what we're going to focus on, which is what our homework's about. Translations, just sliding it, just getting from one place to another by moving it left or right and then up and down. Okay. So if we look here, the definition is to vertically and or horizontally slide a figure. That's what translation means, to vertically and or horizontally slide a figure. And then we saw a picture here, and when I want to describe how I'm sliding it now, because it's one thing to just say it moved, but we have to describe how it moved. And so we used some words. We said, okay, looking at the points, just looking at those vertices, right, the vertex, what happened to go from B to B prime? Old B to new B. I went forward 6 units, and I went down 3 units. Okay, does that happen to all the vertices? Let's see. Let's look at C. Forward 6 units, down 3 units. Let's count 1, 2, 3, 4, 5, 6. Yep, and down 1, 2, 3. Yep. Now let's look at A. 1, 2, 3, 4, 5, 6. Down 1, 2, 3. That's right. So each of these go forward 6 units. And you guys know this is forward, right? Going to the right, going this direction is forward because these are all positive numbers. So going to the right is forward, going to the left is backwards. And then going down 3. Each point did that. So we don't have to do that for every single point. We just got to do it for the endpoints, the vertices. If we can just move the endpoints the way it shows, we're good. And so we did words. Every point in the pre-image moved 6 units forward to the right and 3 units down to move to the image, the new. So we all decided yesterday that that was too much of a big description, right? That's too many words. Am I going to describe every translation? I mean, you could use these words, a full sentence. Every point in the pre-image moves 6 units forward to the right and 3 units down to move to the image, the new shape. Okay, you could say that every time, but then we looked and saw sometimes, yes, sometimes math does make things easier. Yes, don't deny it. Sometimes it does make it easier. So instead of all these words, is there a notation we can use? And the answer is yes. We can use coordinate notation. Okay, and what this is saying is, okay, X, Y, this is my original point, and this little arrow says my original point moves, right? That arrow means moves in this fashion. It moves that way. And how does that move? Well, X plus 6, that means X goes this way, right? So whatever my X is, I move 6 forward. Plus 6 means go forward. And then my Y is the up and down, right? This is telling me I go down 3. So Y minus 3. So whatever the Y is, I decrease it by 3. So this means forward 6, and this means down 3. And so we have fancy names for that. That plus 6 for the X, because the X goes this way, that's called a horizontal shift. Horizontal, because horizontal goes left to right. So whatever happens to the X is your horizontal shift. Whatever happens to the Y is your vertical shift, because Y goes up and down. And that's it. So that was yesterday's notes. So any questions about yesterday's notes? That was a quick overview. Some of you are saying, okay, mister, a lot of words, a lot of definitions, a lot of thinking and visualizing, but I understand better if you show me an example. And if you're feeling like that, you are like most people. Most people need to see an example. You can teach them anything. You can teach them all kinds of stuff, but if they don't see an example of what you're talking about, they will never truly understand it, right? And of course, you have to actually try some examples yourself, get your hands dirty in order for you to completely understand stuff. So you need to see an example. So of course. So here we go. Number 1, this example here. Oh, sure. Someone asked me if I can zoom into here, right here. Or the picture on the side. So someone asked if we can zoom in on the translations. Yeah, right there? Okay. So as they're copying that, if you look at number 1, there's nothing on the coordinate plane. There's nothing. It's blank. So we're going to have to draw both shapes. We're going to have to draw the original and then the moved one, the pre-image and the image. So it's telling us rectangle QRST. So you see how there's no prime, there's no little apostrophe. So that's the original, QRST. That rectangle is the original one. And we're going to have to draw it. And they give us the vertices. Remember, vertices just means those corner points, the vertex, each vertex. Yes, I am recording, and I will put this up. Every lesson is recorded, and I put a link to the recording in our Schoology folder. So yes, I am recording. So rectangle QRST is our original, and they give us the coordinates of each one. And this is why we practiced plotting points yesterday, because I want to make sure you can plot the points. So Q is -6, 1. So if I go backwards, 1, 2, 3, 4, 5, 6, and then down 1, there's Q. last semester's recordings are there, but they're in your archive. They're in your archived courses. Do you guys know how to get to your archived courses? I can show you that before we leave today. So yeah, so some of you want to see last semester's recordings. Yes, they're all there. There's all the folders. Remember all those folders from that semester? You think they're gone? No, they're in that course, but that course has been archived. It's put somewhere else. So I can show you how to get there after. So yeah, that's a great question. Okay, so that's Q. Now let's do R. R is -3, 1. So R would be -3, 1, 2, 3, and then +1. So it would be right there. So there's R. S is 1, -5. So 1 and then -5. 1, 2, 3, 4, 5. That's S. And then T would be -2, -7, which would be backwards 2, and then down 1, 2, 3, 4, 5, 6, 7. Okay, and that's T. And if I put these together, if I connect the dots, connect the vertices, there is my rectangle. Yay. Okay, that's the original. That's the image. Okay, everyone clear on that? All I did was plot the points to get my image. And we know that's the image, that's the original, because it's just QRST. There's no little prime there. So now, how do we draw the new image? Well, we look at, what is it called? It's called coordinate notation. We pay attention to coordinate notation. Now, if we look at number 1, there is some coordinate notation there. They're telling me my XY, that just means every point, my original point. So that's what that means. So in your brain, you're saying, oh, that represents original points. And this little arrow means moves. And then all of this tells us how we move. This tells us how we move. So how are we going to move? Well, X is going to be adding 5. That means my horizontal shift is +5. My X's add 5. So that means I go forward 5. Forward 5. And this is telling me I'm adding 7 to Y. Remember, Y goes up and down. So this is my vertical shift. So what am I going to do? I'm going to go up 7. So that's how I move. That's what this tells me. My original point, XY, is going to move. That's what that arrow says. And it's going to move forward 5 because that's a horizontal shift. The X goes back left and right. So I'm going to go right 5 or forward 5. And then my Y is going to be adding 7. Y goes up and down. So +7 means go up 7. So let's try that. Forward 5, up 7. So here we go. Forward 5, 1, 2, 3, 4, 5, up 7. 1, 2, 3, 4, 5, 6, 7. So there's my new R. So that I moved R, right? So I started with R and I went forward 5, up 7. There's my new R. And how do I say a new R? I call it R prime. Forward 5, up 7. So let's move your Q. Let's move our Q. Forward 5, 1, 2, 3, 4, 5, up 7. 1, 2, 3, 4, 5, 6, 7. Hold on. Someone say, Mister, can you do it in a different color? That's fine. I'll do that. So that's R prime. And then Q was forward 5, 1, 2, 3, 4, 5. So that's our new Q. So I'm going to call that Q prime. All right, let's move S. S would go forward 5. 1, 2, 3, 4, 5. Then up 7. 1, 2, 3, 4, 5, 6, 7. So that's my new S. So I say S prime. And then let's do the same thing with T. Forward 5. 1, 2, 3, 4, 5. Up 7. 1, 2, 3, 4, 5, 6, 7. And there's my new T, and I call it T prime. And then I connect those dots. I connect the vertices. And look at that. Look at that, ladies and gentlemen. It's the exact same shape. It's just shifted or slid to its new position. So it started here and it went forward 5, up 7. And if you look, they are exactly the same. They are congruent, two congruent rectangles there. Okay, and how did I do that? I used this. This is telling me, this is kind of like my map. This is my original point. This arrow means moves. And then this tells us how it moves. Forward 5 plus 5 on the X means X goes left and right. And then 7 on the Y means I go up 7 because Y goes up and down. And that's how we do it. Give you a minute to copy that down. Because remember, some of you love, and this, I think this is a good way to do it, to just watch as I'm explaining, watch as I'm doing everything, and then write it down. Because some of you have a hard time watching and writing at the same time. So if you were just watching, now I give you a chance to copy. And if you have any questions, remember, if you're afraid to ask, dance with that fear. I'm not going to tell you don't be afraid because that's the wrong thing, right? That's what we learned. Go ahead and be afraid, but dance with that fear and you lead the dancing. Don't let the fear lead the dancing, and then take a little chance. Ask a little question. Right? That's how we deal with our fears. We don't let our fears dominate us. We dance with it, and then we lead the dance, and then we take a little chance, and then we take a little bit more of a chance next time. We take a little more next time. And then we're dancing with that fear. The fear's not gone, but we're leading the dance now, right? So if you have a question, please ask me. Miss Rivas is here too. You can ask her. Like if you're too scared to ask me, which is fine, you can ask Miss Rivas. She's a lot less scary. I don't know. People tell me I'm scary, and I don't believe it. But all my sons tell me, Mister. I mean, they don't tell me Mister. They say, Dad, you're scary. And other students have told me that, but I don't think I'm scary. Boo. All right, let's look at number 2 before we stop for the day. So number 2, we have a triangle. Triangle CDE. Okay, so if I plot these points, C is 2, -1. So C is 2, -1. So there's C. D is 7. 1, 2, 3, 4, 5, 6, 7. -4. 1, 2, 3, 4. So it's down here. That's D. And then E is 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's E. So I'm going to connect the dots. Connect the dots. La 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 la. All right, so that's my pre-image, right? That's my original image. And so what do I have to do to get my new image? Well, let's look. My original point moves x minus 3. So x minus 3 means I go backward 3 units. Backward means to the left, right? Backward means to the left. And then y plus 8 means my y is vertical, right? Means I go up 8 units. Okay, so let's do that for each one. So C, I'm going to move C. I'm going to go backwards 3 and then up 8. So backwards 3, up 8. So here's C. I go 1, 2, 3, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there, C prime. The new one, you put that little prime on there, right? E, I'm going to do the same thing. I'm going to go backwards 3 and up 8. 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8. And that's E prime. And now let's move D. Let's move D. I'm going to go backwards 3 and up 8. So backwards 3, 1, 2, 3, and then up 1, 2, 3, 4, 5, 6, 7, 8. there, and that's D prime, and then I connect those. And looky there. Exact same triangles, just moved. The purple one is the pre-image, the red one is the image, purple one is the old image, red one is the new moved image. And how do we know how to move it? That coordinate notation. This tells us everything. This tells us how to map everything, how to move everything. Okay. All right, that'll be it for today. But I do want to show you, before you go, I do want to show you. Now, we didn't finish all the notes, right? If we look here, we look at the next page, there's some more examples. And then the last thing we need to know is how do I identify and how do I write the rules, right? There's the two pictures there. How do I write that rule with the arrow and the X, Y, right? We got to practice that. So since we didn't do that, I'm going to have the homework due tomorrow. Is that fine with you? You guys okay with that? I'll have it all due tomorrow. How do you guys feel about that? Okay, yeah. Okay, so homework will be due tomorrow. Homework will be due tomorrow. Okay. So have a great day, guys. If you want to stay around, I'm going to show how to get to your archived courses. I'm going to show you how to get to archived courses so you can see. Yes, the whole page. It's only 8 problems. The homework is 8 problems. The homework is 8 problems. And yeah, it'll be due tomorrow, not tonight, because we haven't finished the lesson. We will finish the lesson tomorrow. Okay. All right. Okay, someone's happy. Any questions before I move on? Okay, have a great day. If you want to stay to see how to get last semester's videos and last semester's folders, you can stay for that, but you don't have to. So the way you do that is you go to your click on courses, right? And so when you click on courses, you can click on right here in the corner. You should see something that says My Courses. Click on My Courses. And then that'll take you to here, and then you'll show all your current courses, but there's a little button. Uh-oh, someone had a question. Hold on. Okay, we'll come back to this. Oh, so down here, we didn't write anything down here, did we? Okay, we didn't write any. All they want to do is they want the coordinates. Thank you. Thank you. I forgot. They want your coordinates of each. So they want to tell you where's Q prime, where's R prime, where's S prime, where's T prime. We'll talk more about that tomorrow because we had a whole bunch of people leave already. But yeah, that's the last part. We draw it like this, and then we put the point, like Q prime would be -1, 6. Right. So you just write the point of where that point is. But we'll do that first thing tomorrow when we talk. Thank you for that. So you go here, and on My Courses, you should see a little button that says Archived. Click on Archived, and you'll see all of your old classes. Right? This one is Geometry A. You can click on Period 14, and you'll see all of our folders from week 9, 10, 11, 12, 13, 14, 15, 16. Okay, have a good day. Bye. So yeah, that's how you do that. And then if you want to go even farther back, you can go back here to Geometry Tutorial Lab, period 14. And that was the first week 1, week 2, week 3, week 4. So it's all there, but you got to go to Archive. So again, go to Courses, click My Courses, and then up here, click on Archived, and you'll see all of your old classes. And you can click on Our Old Class, and you'll be able to get to the folders and the videos and all the stuff that's there because it's all still there. All right? All right, everyone, take care. Have a great rest of your day. And remember, homework's not due till tomorrow, and I'll see you all tomorrow. Thank you, Ms. Rivas, for your help. See you tomorrow. Bye.